Okay, good evening. Thanks everyone for coming. New venue, so appreciate your feedback if you catch me later. Thank you very much to Sainsbury's and particularly Mark here for actually getting it organised for us. And for free beer and pizza. Okay, we're always looking for people to give these talks. So if you go to phplondon.org, there's a link on there. Maybe do it on your desktop tomorrow because I've not done the responsive styles yet. But if you go there tomorrow, you'll be able to see the Google Talk submission link and submit for at some point throughout the rest of the year. I think we've got 1 or 2 lined up, but yeah, we're always begging people to speak. So please, if you think you can speak in front of a room of 100 people, submit and we'll get you up here. I'll remind you at the end, there are a couple of pubs nearby. I've forgotten the names again, so I'll ask Mark at the end what those are. So we'll move on to there if anyone wants to. But other than that, I'll just hand straight over to Paul.
Good. Test. Testing. Cool. Cool. Hello. Can everybody hear me okay? Can everybody understand me okay? Maybe? We'll see. It's really awesome to see that many people come to a user group meeting. I live in Glasgow, Glasgow PHP in Edinburgh and stuff. You know, you're lucky if you get 25, 30 people. And we looked at the RSVP on meetup.com for this event, and it was like, last time we checked, it was like 251 people said they were going to come. So for me, that's just insane to see that many people, so that's cool. Yeah, Docker, right? This shiny, magical unicorn that's going to solve all our problems. It solves a lot of problems, but it also creates some of its own, right? Because there's no such thing as free. Yeah, this talk, I hope that most people will get something from this talk, wherever you are at in your journey of doing maybe Docker things or doing automation. If maybe you don't care about Docker, but you care about like continuous integration and testing and automation and stuff like that. So there's a bit of everything in this talk that hopefully you get 1 or 2 things from that you can take away from this. So I do want to get a few quick questions just to get a good feel for the demographic here. Raise your hand if you're already like seriously using Docker, like you're right into it. So maybe 20% maybe. Who's using Docker in production? Okay, less people. Who's using Docker in continuous integration environments, right? Building. Okay, again, not that many, right? So putting the Docker stuff aside, who's using Docker for development type things and messing around, but they're not actually doing it in CI systems? Okay. Putting Docker aside, in general, like continuous integration, like automation, using things like Jenkins and stuff like that. Who's doing continuous integration? Who's using Jenkins? Okay, good. That's pretty much like 90%, so that's awesome. So you folks are probably the ones that will gain the most from this talk because you already got a good familiarity, a good understanding about continuous integration, is about taking that leap towards using Docker. Okay, so just to introduce myself in case we haven't, there's a lot of new faces here. So I'm from Glasgow, software consultant, and I specialise in quality assurance engineering. And that's my Twitter handle if you want to keep in touch or want to chat. And I've got an email address there if you want to send me anything. Anyone who wants to take any pictures, feel free to. I would appreciate if you take some pictures, just so I can show the family and stuff like that. To tweet them or just pop them in an email, that'd be great. Yeah, full stack. What does that mean? Pretty much nothing, right? But this is the troubles I get myself into, and not often. But it's usually around environments, consistency of environments. How can we get the development environment to be as close, the CI to be as close to production as possible? These types of things I find it hard to sort of sleep at night sometimes, knowing that there's inconsistencies between environments, and that's why I invest a lot of my time in Docker, because that's one of the problems it solves. Ignore the first line; there shouldn't be there. PHP wise, I do PHP fix stuff. PHP from time to time do some core extensions, and I was heavily involved in the modernization of the PHP.NET website. Because I woke up one morning and get really pissed off with it and said, okay, this needs to be better. And we spent about 1.5 years actually modernizing it, taking it from the old, the old and busted to the new hotness, right? And in doing that, I broke the whole infrastructure a few times and took down the PHP.NET website in every country. So nobody told me you can't use sessions. Yeah, there's no sessions in PHP.NET, so they use cookies for everything. That's great, right? So I'd done like a session start and I pushed the code up to master, and then all of a sudden the traffic went from 4,000 concurrent users to like 3,000, 2,000, 1,000, and I'm like, what the hell's going on? And then somebody just rolled back my commit, and everybody's got a website again. So I break it a lot, but hey, it's because there's no staging environment for PHP.NET. It's terrible, right? But you can't actually test your code until you push it to master, and then all the websites just propagate an update. So it's kind of like what? Yeah. Nobody's stupid enough to give me access to those machines. Yeah. So that's that. The project I will spend a lot of time on is PBI Framework Engine. I won't talk about that really, but that's the website. If you want to check it out, take it out. I've been using PHP since 2001-ish, and I've been using Docker for about 3 months. But those 3 months have been about 12 hours every day for 3 months. I'm not playing with Docker. I'm actually using it heavily in businesses, all right? So I've got however many days are in 3 months, right? Every single day is hardcore Docker stuff over and over and over. So I've got an intense amount of experience in a short period of time. And the stuff you'll see today is the journey I've taken and the lessons that I've learned. And looking back on it in hindsight, I feel there's a lot in this talk that if you're looking to move to Docker to get better benefits from it for your pipeline, these are the things that you should need to know, okay? So continuous integration is just automation of commands, right? So this is a command. You can maybe half read it, right? It kills some processes, but maybe can you read something like this? Probably not, right? Take you a while to figure it out. So automation is really taking these commands and sticking them into files. So the first one's like something like kill Java, right? Or that one, the big long one, right? It's to do with like referrers and Googles and nonsense like that. Or something like that, right? So you can use Selenium, and I've got a Selenium script that orders my curry for me when I get home from work. I just press the button, and using Selenium, it just goes to Just Eat, puts my login details in. It knows my favorite, so anyway. Automation. It's fun. And yeah, Selenium makes it awesome. What's up? Yeah? No. Maybe I'll put it there, but yeah, exactly, right? So we've got continuous integration, we've got continuous CD, right? And it can either be, D stands for deployment or delivery, and they're two distinct things. Delivery is that it's good for teams, and depending on what you use, what one you want to use depends on your team and your project, right? Delivery is probably good for teams that have doing sprints. So at the end of the week, or at the end of your sprint, you want to ship a new version of the software. That's continuous delivery, right? You decide when you press to go live with that new version. Continuous deployment is different, where if your build goes green, it's going to promote the build automatically and deploy automatically, okay? It's depending on your project. You've got two distinct things. Pipeline. People ask me what a pipeline is. Pipeline is a general concept, like a data pipeline, right? In Linux, we've got the pipe character because it's stuff going through a pipe. So, yeah, it's just going from A to Z through a series of steps. And a pipeline can just consist of jobs and lots of jobs. And the key point about that is, just remember that, that's a key point. and they have their own single responsibility. So rather than having one big job called build, and it does about 15 to 20 different things, have 20 jobs. Okay, and you'll see why. What to put in your pipeline? The most important thing to put in your pipeline is a lint checker, because you don't want to spend half an hour to get into a build queue, to run your build, to run your test suite, to then PHP unit falls over and says your test failed, and you go, why? I forgot a semicolon, right? The lint checker will tell you within a couple of seconds. So yeah, lessons learned. Put a lint checker in there, and if you can, run your unit tests outside of Docker if you can, because there's an overhead of actually doing the Docker steps and running the containers up and then running your unit tests and other types of tests in the containers. I need to do that for the project that I'm working on right now because I need extensions enabled, like things like Redis extension and all other nonsense. But I wish the unit tests didn't test the Redis functionality so that I could just run them on any machine with PHP installed. So be conscious when you're building your unit tests. If you can get away with not relying on too many like system environmental things, then go with that. And after you do your basic stuff, you want to start doing things like this, right? You want to have jobs to do these types of tests. Stress testing is quite fun because regardless of how green or red it is, it's more challenging to do stress testing because you need to do lots of like logging and analytics, and then you have to review the results of the stress test to see if the changes you've made have made the response times go up and down and all that. Error rates have been up and down, so that's like a big black hole, right, of horrible stuff, but need to do it. Yeah, so you've got a pipeline, you've got like what, maybe 5, 10, 100 jobs potentially, and how do you link them all together? So this is called triggering, right? And in Jenkins, it's called triggers, and in Jenkins you have things like upstream triggers and downstream triggers. So an upstream trigger is if this job here is trying to be invoked, it has some dependency, it needs to like a prerequisite of it. So you can say, set an upstream for that. So if you've got like a unit test bot job, you want to maybe set an upstream trigger of prepare environment, right, or something like that, so that it will run that one first, and then it will come back, right? Downstream is really just going through the more traditional way to set up your pipeline, and that's like a sequence of steps. And in Jenkins, you can put logic in between your triggers, so you don't have, it's not just one linear line from A to Z. You can actually have logic. So like based on some kind of thing that's happened, like what am I building the master branch instead of a feature branch? You might want to do different things. So you can go linear, and then you can branch and go and do some optional triggers, or optional jobs, and come back to the main pipeline, right? So triggering is really powerful, and if you actually understand it or get quite good with it, then your pipeline becomes stronger, right? And kicking off your pipeline, there's usually 2 common methods, and it's either when you push a commit, or you can do manually triggered pipelines, manually triggered stuff. Parameterized, Jenkins has something called parameterized builds, which really is amazing and changed my life when I actually discovered it for the first time. You can set up custom questions to ask the person manually running the job, like what's the branch name you would like to run, or would you like to run the Selenium, the end-to-end test suite, yes or no? Like, then you can default to no, because it may take a while, and you don't want to do that. So parameterized builds, remember, check that out. A lot of good stuff to do. And just when you've got all these jobs, there's 2 plugins for Jenkins that I recommend. You've got this one, which is just a visualizer, and you've also got manual intervention as well. So it won't go. That's not an auto trigger. It's like a manual trigger. So it's set up, but it won't do anything until you actually click it, and it will continue with the build. The reason I was saying that you want lots of jobs and not one small job is because you can continue from the point of failure before. Let me try and say that again. If you've got one big job and it fails, you have to rerun the whole job, right? But if it does 5 green jobs and the number 6 fails, you can continue from 6 onwards because you know what 1 to 5 worked. So you gain a lot of time doing it like that. Okay. Projects I came into, and it's just one big job, monolithic job, and you could got right to the very end, and it's the very last part of the field. You have to go through the whole thing again. So I recommend putting a lot of effort into having small jobs. These plugins let you rerun them. So if this was on the screenshot, if like the middle one was the acceptance test was red, then there would be a button on that that says like rerun from this point onwards, right? So there's these plugins help. This is called the build pipeline plugin, and this is called delivery pipeline plugin. They're basically the same thing. They're just different plugins, and they look quite differently, and they've got some slight modifications and functionality. But yeah, that's something. And this is just generic Jenkins stuff. So this changed my life. Literally changed my life. For me, this was the biggest takeaway from learning things for Jenkins. This is called the Job DSL plugin, and it's implemented in GroovyScript, all right? And it lets you write GroovyScript, which is basically this stuff, right? And instead of you manually going through Jenkins and creating jobs, and then going into the jobs and into the big text editor, start hacking away stuff inside there, and then if you want to change like the log rotation, for example, and that's like someone changes their mind about how often the settings for the log rotation should be, you have to go through all your jobs and change that one value, right? You don't really get good transparency or a good picture of what's actually in the jobs at a glance. You have to click through Jenkins and see what people have put in boxes, right? And people can just go ad hoc and change what's in the boxes, and you're not going to know, right? Drives me insane. So this thing is amazing because it's in code, right? You actually design your jobs in code and put the settings in there for them. And that's a repo. So you've got change control. You know who's changing it. You can create pull requests, right? And this job plugin, so these are functions like shell, right? That's a function. Now, to something you can do in Jenkins. There's lots of plugins for Jenkins, but this job DSL plugin has 127 plugins that it supports. So the next one, right? Shell, but like the Git plugin, there's an SVN, right? So you get the point, like Maven, all of the stuff. So we're kind of moving more into the Docker land now, right? And I will show you exactly what's inside these scripts as well. So this is called a job called unit tests, right? And then you got another job called integration tests, and then you got another job, and you can see the point, right? Ideally, this is my pipeline, general pipeline. This is the steps that my job line consists of in general, but this is specifically to Docker, right? So you want to do some build setup process, and then run your tests, save some artifacts, publish the image, and clean up. And the important part, lessons learned, is always make sure cleanup runs, regardless if it's pass or failed, right? It's like a final, you've got try, catch, finally. That's the finally, okay? You want him to run. Otherwise, your server's going to run out of disk space real quick, unless you throw like terabytes at it, but that's just wasting money. I'd say like before I got really experienced at this and really aggressively done cleaning up after ourselves, I'd say about 25% of the time the jobs were failing, it was because the server ran out of disk space. It's that important because Docker can use up quite a lot of space depending on the way you use it and what you're doing with it.
So is there effectively a finally, as you would with an exception, is there a way to say that shall always run this cleanup?
Yeah. Just Google for it. It's straightforward. You just say, yeah. It's just in the settings for jobs and triggers and stuff. There's like the triggering setup. You like always trigger this guy, and there's settings around triggering.
Those steps are terminated if process exit code is not a 0.
Yes. In Jenkins, a job fails, right? It's the same. Have you used Jenkins? Yeah, so it's the same. It's just that text box that you see, that you type into, that's the text box. Okay. This is just, so you could have like multi-lines in here and have, I'd like to have shell scripts because it actually explains what's happening. But you could just put all your commands in these, right?
Okay.
So that's the same. Yeah. The DSL doesn't just do like the shell, it's got all these functions as well. So in Jenkins, there's like the folder plugin. Previously, you've seen those screenshots of like creating delivery pipelines. So you can actually create all this, all in code, straight out of the box, and test it locally on your own machine before you even touch like a Jenkins production server. So yeah, this opens up so much cool stuff, right? So that's probably what I want to give some attention to. So Jenkins is great, right? But there's problems with not using Docker, right? And that is that there's usually, for one machine, it's one slave, right? And that means it's one environment for all your jobs to run on, right? And your jobs may have different requirements. They may be built in different languages, so they might need different versions of PHP or different versions of Java or MySQL, right? And you have to install all the stuff for every type of job that or piece of software that you're running in this one machine, and it's just a clusterfuck, right? It's nuts, right? So, as a result, the CI environment you're building your jobs in is this hybrid system, right? It's not a box with just MySQL on it, it's everything's in this one box. So to be honest, your CI is no longer like what your prod is like, because it's all crammed in one box. And prod production, of course, is not one machine; it's different machines. So, yeah, that's the problems that I get with Jenkins. So, this guy, right? And it comes to the recipe because it's easy to change the infrastructure in your apps repo. So the branch that you've made, you can actually modify the infrastructure as part of your branch. And when your branch gets built on the CI server, the infrastructure is built, and you're defining that. And as a developer, you're in control of the infrastructure, right? You don't have to rely on a sysadmin to come onto a Jenkins box and install some things for you, right? And the result is Docker will give you unified architecture, because the image that gets built and ran in CI is also the same one that's on your development environment, and of course it's the same image that's going to get used in production if you want to use it in production, right? So it's one image, and it's a redish, like an exe file in Windows. You've got this exe, and you can put it on any machine and run it. This is conceptually the same thing. So Docker, I'm not going to go into like what is Docker, like intro to Docker, but this is how it is able to do the stuff it does. The kernel's got namespaces and C groups, and Docker uses a thing called libcontainer. And your stuff is completely isolated from the host machine. It allows you to run your code directly on the box, in the kernel, but it's isolated from the other things that are on the box. And this is the screenshot from docker.com. You don't need OSs anymore, you don't need Vagrant, don't need OVMs, because it just runs straight on the engine, straight on the kernel. The point about this slide is that based on your operating system, you will find Docker easier or harder to do. Linux is the best choice because it's straight Linux and the kernel's there and it can just run stuff. If you're on Windows or Mac, then it has to create a very small VM, very small VirtualBox VM on top of like Mac or Windows, and then Docker runs in that thing, right? So it's not native on the host, and there's some caveats to that, right? So that's why I'm usually using Linux in the office, and I have my Mac because I like Macs, but I'm actually using Linux now more and more because of this reason. But Mac, the news is out. Docker's just released a beta of a new version of Docker, and it has native containers, native support for Macs. So there's no VM anymore for Macs. It will be straight on the Macs kernel. So that's pretty groundbreaking. So I'm quite excited about that. This is called the Docker Hub. It's an official repository. It's kind of like packages.org, but for Docker. And Docker themselves, so there's official maintainers. And pretty much if you've got an idea, like for Selenium or for PHP or any software, there's going to be an image on there for you, and you can just start running that. You don't need to write any code. You just say Docker run, the name, and you've got that thing that you wanted. So this is an overview, right? So it's pretty traditional, straightforward, right? The idea, you run your stuff, you run some more stuff, and then you've got deployment, right? Here's another one, a bit more in detail. But there's a new thing here called Docker Registry, all right? Docker Registry is, I think a good way to explain it. I don't really have one, but a Docker Registry is somewhere you push images up to, right? The Docker Hub I mentioned, that is a Docker registry. It's just a public one. You will want to install a private Docker registry for your own images, the images that you're building for them to go into, right? For you to push into, or your CI server to push to. It's kind of like packages.org versus using something like Status, right? So you have your own internal things, but you want to do Composer, nice stuff. Same idea. All right. So the Docker registry is where the images that you build for your project, that's where you push them, and it's a push-pull model. All right. So once you push it in CI, you can then pull it on any environment you want. So because it's in the registry, and then the production server pulled it down and then ran it, if there's a bug in production, you can just do a Docker pull, the same image from the registry onto your local machine and just hit run, and it runs. Because there's no, it doesn't care about the host that you're running it on, because everything it needs is inside the container, and it's redistributable. So that's where you get the unified architecture and the consistency between environments. So you can actually run prod on your own machine now, and it's pretty cool. And this is probably the last slide before I show lots of code. There's a Docker plugin for Jenkins. I don't personally use it. I do the same thing as what the plugin is doing, just by chance. But the reason, so this diagram illustrates why you get the benefits, what benefits Docker can bring to you, and that is that each job that you run concurrently, 5 at one time if your machine's big enough. Everything that your application needs, all dependencies like a Redis and a MySQL or a Postgres, Elasticsearch, whatever, they're all inside of that little container. And now you could have PHP 7 in that one, and you could have PHP 4 in that one, right? Or you could have MySQL or Nginx Apache, right? So that's the idea. You get the flexibility, and what containers run and what's inside those containers is defined by the developers in the code, right? And it's very easy to do because it's actually a YAML file, right? That's pretty straightforward. So that's why you can scale, right? And if you've got multiple servers, then it's amazing because you don't have to change your mind about stuff. You can just change your mind in the code and then run, and you don't have to maintain. The only thing I actually go install on my physically on the Jenkins slave boxes are Java, PHP for PHP command line, and Docker. That's it. I only install 3 things. And if you're using AWS, for example, all you really need is like PHP and Docker installed, 2 things. And then you're ready to just run an image on that box. And that comes up real quick. So you can think, before if you're using Vagrant or Puppet or Chef or Ansible, and you actually have to spin up a new box and you have to sit and wait for it to provision and compile on that box at runtime. With Docker, it's all pre-compiled, and it's in the image, and the image is in your registry. So your whole system's ready to go and ready just to be turned on. Like your TV being on standby, right? Effectively, that's what it's like. So if you've got a box, if you're doing scaling in production with Docker, as soon as you've got that box available, you just do Docker run, and it just runs it, right? There's no provisioning step; it's all pre-provisioned. So, any questions so far on this?
Yeah, actually, when you were talking about everything's all pre-provisioned, I was wondering how you sort of might have dealt with the challenge of things like environment variables.
Hello. So, okay, got my voice now. So how you might have dealt with the challenge of like environment variables for database passwords, that sort of thing?
So they're on I use Ansible is good for server orchestration, right? There's server orchestration and there's configuration, like provisioning stuff, right? I use Ansible and I tell Ansible, like, these are the 10 web nodes, right? And it goes and does something on that box. But the only thing it's doing on that box is setting environment variables and then doing Docker run, right?
Okay.
So I'm doing it because everything's still in Ansible. It's all defined, like these environment variables, these are the host names and passwords and stuff. And these are the boxes you're going to do. And this is the Docker image that you're going to run on these boxes. And I just tell it to go, and then it'll do the Docker run command. A better way to solve it is I've been using console. Are you heard of that? Are you aware of that?
Yeah.
So I use console and I use Vault in front of console, and that's how I securely do my credentials. But if I'm cheating or I'm being lazy, I just put it all in the Ansible file with the environment variables and hope for the best. Right?
And then push it up to GitHub, yeah?
What's that?
And then push that all up to GitHub.
Yep,
yeah?
that's the way. Yeah, so the Docker Jenkins plugin does this. It connects to any machine that runs Docker. It makes it a Jenkins slave on the fly, runs your jobs, and then deletes it. So the boxes aren't actually have anything on them. They just get used, and then anything that gets kept, like artifacts, are pushed up to the master and saved on the master box. So that's just what the plugin does. I don't use it, but it's pretty cool. Anyway, this is where the fun starts. So all my lessons learned and all my experiences in the code and in the commands, right? The little flags that make the difference, and like like don't cache and stuff like that, makes you mad, drives you mad. But they're all in here, so it's goodness. So we've got PHP environment, right? So Docker has a Docker file, which is like a make file, like the compilation file, and this is an example of a Docker file. So to get a web server, right? This is all you need. The from part is important. That's going to pull that from a registry, which is your own one or the Docker hub. So if I want to just change from PHP 5.6 to 7, all I need to do is just change this to 7.0, and that's it. And I'm using PHP 7.0, right? This is me installing Nginx, right? Because I have to use apt-get. But the important part here is I do apt-get update. And what happens is every time I build this, like on CI, when I do a build, it'll build this file. And if there's any security patches that have been released, this apt-get update will catch it. You know, if you were like, oh, how do I update my live servers because there's been an SSL security flaw. This design, this apt-get update, will keep it in sync constantly. So it's good to have it in there. And the apt-get itself has lots of quite aggressive caching, so it's going to fill up your disk quite substantially. So you want to get rid of all that stuff. After you've installed what you need, like for me, it's Nginx plus some nano and wget and git. I purge it and I do these guys, and that's it. So I have I got from apt-get, but then I delete the cache. That's important because this Docker images are the size of the files on disk, effectively, right? So whatever these commands do, whatever files they make, that's the size of the image, all right? So by cleaning these out, it keeps your image size quite lean and quite small. That's good. The Docker has these things called, these are like Docker commands or whatever, that workdir, env, and run, blah, blah, blah. These, every one of these is a layer, okay? So Docker image is about using layering. Go into more detail on that. So every time you do a command like that, it adds overhead, right? It adds time, and it also adds size. So because of that, we wouldn't, you might see people doing like run and then something and then run and then something and run. And every time you do that, it adds megabytes overhead every time, okay? So in Docker land, what we do is we only want one Docker run command and we just throw everything at it, okay? And that's why we use the backtick and the ampersand. So we do everything, but this will create one layer of our software, okay, of the image. And that's why you'll see that, and that's important to follow because you don't want your image to be 2 gig. You want it to be something like a couple hundred meg max. Yes?
How do you make sure that once that layer has been created from that concatenated run command, that apt-get update, for example, is then is still run periodically?
It's still what?
It executes periodically.
Because you do the build it periodically. You know what I mean?
You build an image.
Yeah.
When you build the image, this gets run in real time.
Unless you repeat the image, that will run again. Stay at the same place.
Yeah, there's no like from the last time you've done a Docker build to this time you've done a Docker build, there's sheer nothing. It does it from scratch every time. So you're going to get fresh stuff every single time. Copy command. Now in Docker you can do either two things. You can do copy or add. Okay, add is the devil. Don't use it. Because one of the reasons is because copy just copies files. What does add do? You can throw anything at add. You can give it a remote. I can give it an FTP credential. Some probably. You give it a host name like a tar file and remote on the internet, and it will bring it down and put it in there, right? But that's not the problem. The problem is add unpacks the tars and then puts it in the repo. But not just the tar you specified. If you've got a directory like dot, like line 19 here, like the dot, like everything in my current directory, recursively, anywhere in that directory, if you've got a tar file, it's going to unpack it and it's going to stick it in the container for you. All right? So that's why it adds a devil and don't use it. unless you actually want to do crazy things like that, but usually you just want to copy files. Entry point, this is the important part, right? A container only runs for as long as the primary process that's running it within it is alive. If that process dies, the container dies. So that's why we do daemon off. So it means we're running Nginx in the foreground. So if Nginx died, the container would die. So that's the point, right? Always running. Next, so once we've got a Docker file, that's cool. We could do Docker run, and like, you can make an image out of this. But we have something better, and it's called compose, and it's orchestration. All right, it's a container orchestration tool, and this is basically now you're defining the architecture. Now, in this case, I only have one thing, and it's just my app, right? But the ports, so build dot, right? Look for that. Look for a Docker file in the current directory. Ports, these are important. There's like 4 variations of crazy things you can do with ports that are super useful. Docker has internal ports and external ports. Okay, internal ports are it can in the previous file it said expose 80, so that container is running on port 80, but it's not. It's exposing it to other containers that can talk internally within their own little private like VPC, like its own private little network. But nobody from the outside world can talk to them, right? Until you tell it. And this is where the left side of the semicolon. So if I was in a box and 80 was already allocated and I wanted this by something else, like Nginx, and this was an Apache one, then I could just make that like 8080. And when you run when you do that Docker compose up, it will forward the traffic from port 8080 on the machine you're running it on to port 80 inside, all right? And if you take this out, it becomes, and this, it makes it random port, which is awesome, which basically means run this, expose a port on the host machine so I can access it from the outside world, but I don't care what port it is, right? And then you can just check the port after it's spun up, all right? So that's super awesome. Like, for example, you've got a build server and you've got more than one build at the one time. If you were just blindly allocating port 80 to this application, then the second application wouldn't work, right? Because it couldn't bind to port 80. So if you do random port, then you can have an infinite amount of this container running, and it will bind to a real port, just a random one, right? So that's why there's cool stuff with Docker and ports. And the volumes is just left to right. Everything on my left-hand side, like the PHP ini on my host, in my repo, my code repo, map it there. So like dev. So if this was a prod thing, yeah, I mean, anyway, that's it. That's basic stuff, right? Next, we have. So we have an image, right? But we want to run tests against it, right? We kind of went into more CI stuff. So we see more cool stuff in here, right? So this is a test, and it's pretty much the same as before. When we're running this this test thing, so we do Docker compose. It'll just look for a Docker compose file by default. We do -f, and we can do docker compose.yaml, which is the same thing. But the reason that I'm showing you this is this test file, it's missing like the things for application, like the port and all that stuff. So what we do is we chain them together. So we say, okay, everything that was in this file was good, but now I want to append to that and bring more YAML into the mix. And then you do -f docker compose.test.yaml. Okay, and now you're running it. Now the first guy didn't need to care about what the second guy's doing. Okay, and the second guy didn't really care about the first guy. He's just providing his own piece of extra goodness to the mix. In this case, I didn't have to build Selenium, and I didn't have to build Phantom.js. There's already images up on the Docker Hub for me, so I just went like YOLO modes and copied and pasted and hit run, and I've got Selenium and Phantom and Node and whatever you want. Yeah, and in this case, I want to set an environment variable in this case for testing mode, right? Because the Symfony debug toolbar at the bottom screws up Selenium. It just like has a seizure and falls over. So you have to like tell your Symfony thing it's in test mode so that you can not enable the debug toolbar and you can run Selenium tests. So that's test mode. So when you run your test suite, this is what's going to happen. Profiling. So you want to have profiling. So it's the same situation. You would do -f docker compose, and then -f docker compose profile YAML. And in this case, there's new stuff. So there's this extends thing, all right? So Docker has extends, and it's saying, okay, create a container and call it Blackfire, and get whatever. But actually, I don't want to write it here. I've got this base file, and the base file has Blackfire in it. So what you can see is quite a powerful. You can have a powerful list of like things in base, and then depending on the context, like docker compose.test, .profile, .qa, whatever you want, you just pull things, inherit it from the base file, and you can tweak things, right? So that's extending, and this is powerful stuff. So that's a PHP environment, right? So if I run this, I'll get build dot, which will give me PHP, FPM, and Nginx, right? Next is multi-PHP versions. So I've got this. So say you want to run your test suite, or you want to run your application, and you want to run it in different versions, right? Either manually, just see if it works, or you want to run it as if from a testing perspective. You can have 3 containers, right? These are the container names, PHP 7, blah, blah, blah. So I would do something like docker compose up, and then if you do docker compose up, it will do every container. But in this case, I don't want to run all of them at one time. I just might want to run one. So I'll just do app PHP 7, and that's it. And I'll go and like the app that's against say localhost or this URL, it will be PHP 7, because what I've got here is a base, right? So application. What is application? It's extending application from the base. So here's the base, and this is application, right? So I'm extending base, and then I'm overriding some things. So I didn't do build with a dot, like look in the current directory for a Docker file. I'm specifying the Docker file it should use. And in this case, I've got custom Docker files, and they are opt build PHP 7. So it's the same stuff, but see that all I do is change that from, and it's different from, and a different from, and that's it. And that's how you can get multiple PHP versions running with little to no effort, just by churning out a small YAML file. All right. And you can do that if you keep this in mind, you think about it, you can keep it a bit more creative. Like, okay, does my code run against MySQL? You know, this version of MySQL, the next one, right? Or Apache. Does my software work okay in Apache, like 2.2, 2.3, 2.4? You get the point, right? You can get creative with this and do testing. So you don't have to, and because you're not installing anything on the actual CI boxes themselves, you're free to just put whatever you want in there. So this is good stuff. This is how you know if you've ever broke backwards compatibility, or you've added that somebody's done like in PHP they've done like : class, right, which is PHP 5.5 upwards. If you've got a PHP 5.4, 5.5, or whatever, when you run your test suite, it will say, oh, by the way, this broke 5.4. You know, do you care about that? Or you do something that was deprecated in PHP 7. Well, if you run it against multiple versions, your PHP 7 build will fail, right? Kind of like in Travis, right? In Travis, you can do this. Travis are using Docker, right? They're basically doing this stuff for you under the scenes, and then you just run it. So it's kind of like doing what Travis does. You get to do it yourself.
It's the Travis test matrix.
Yeah, so that's pretty much roughly what they're doing.
Yeah, it's the Travis test matrix of different versions of software, maybe different versions in Composer, and different versions of PHP as well.
Yep.
But you're just doing it all yourself.
Yeah.
Within your own local environment. Excellent.
Yep. Put in there what you want, what's important for you and your projects. And off you go. So that's multi-versionings of things. Let me see. Next, we'll talk about base images. Okay, this is important. If you look at, let's say, a Docker file. So they say this was the Docker file for your project. Nope, not that one. This one. So this is typically a Docker file, right? And it has lots of like crazy things in it. Like down here, you've got Docker, so you want to like install extensions, right? And here you have to like pull down the Redis one from GitHub and do some crazy stuff to it, right? Anyway, there's a lot of stuff in here, right? And if you run a build, it's going to do all this every time you do. So if you change like a CSS, it's going to have to do all this compiling, right? Compiling takes time. So how do we avoid compiling every time? Well, we use base images. And base images are, if you look at a Docker file and you see that from, that's a base image. That's an image you're taking and adding your own layer on top of that image, or own layers on top of that. So what we do is we isolate our environments into two. And the reason for that is your code's changing a lot, but probably the PHP extensions you're using, or Nginx isn't changing very often, right? So you don't need to recompile it all the time, right? You only compile, you only need to run compile steps against this when you've changed something in here. But for the most part, it's probably going to be pretty much stable, and you're just want to run code level changes, right? How do we do this? So on CI, I've got a job that kicks off every hour, and every 1 hour, I've got a base image job, right? And it does a Docker build, and it pushes it up to my Docker registry, okay? And then, now my application looks something like this, right? So rather than doing from PHP directly, I'm doing from my image. So did that make sense, what I'm doing? Okay, so this means if the base image, for example, the base image runs every hour, right? So if there's been a security flaw, that's got an apt-get update, doesn't it? So if there's a security thing, by design, all your child images will be secure or get that update, right? And if you need to change something in your Docker file for your app, like you're adding assets install and there's extra Symfony stuff there, it will have to redo the Docker build, but it will only do it for this part. It won't have to go through all the compiling stuff. So that's the idea. So